So in the previous lecture, we have seen that what is a directional overcurrent relay, and we have also seen its construction, its torque equation, and its characteristic. Now we will see its application and its working. So just recalling previously that what is a directional relay? A directional relay is a relay that will operate in a particular direction of current only. Now consider this figure in which this cross sign over here, just see the pointer of my cursor. This cross over here shows the position of the relay. It is placed in this line. Now this relay will operate only when if the direction of current is in this direction of this arrow, that is from left to right. Now if the direction of this current is reversed somehow, that is from right to left in this direction, the relay will not operate. Now suppose there is a generator and this generator is supplying power to the load. That means the generator is supposed to supply current from generating part to the load part, to the load end. Now in general, a generator is the generator of electrical energy and it will supply power to the load. Now what happens if the current starts to flow in the opposite direction, that is generator start to absorb power from the load, then that means there is something wrong. So the directional relay should be placed such that if the current is going into the generator, and if that means there is something wrong, and it will avoid and it will operate and eradicate that particular situation. Although the possibility of this thing to be happen is very much minimum, but now you will get an idea that where we have to use a directional relay whenever there is a reverse flow of current. So in practice we use directional overcurrent relay. What is directional overcurrent relay? Again I will say that is the relay that will operate if the current is flowing in a particular direction, and that too it must be above a certain threshold value, which is called its pickup current. Okay, so where to use the directional relay, again we will say. So if in the case of any event of fault, when the current is reversed its direction, that is it does not flow in the general direction in which it is supposed to flow, then we need to we need to put a directional relay over there. Now how to find the direction of current is reversed or not? It is totally based upon the occurrence of the fault. Now, one golden rule you all must remember, that whenever there is a fault in any part of the network, in any part of the system, the entire current from all the possible sources will feed that particular fault. What was the reason for that? That is, whenever there is a fault, the current will get the minimum impedance path over there. So all the current from all the possible sources will flow in that particular fault, feed to that particular fault. Now consider this system. This system consists of two generators and 7 relays. This cross position 1, 2, 3, 4, 5, 6, 7, these are the position of the relays which is being placed to protect this power system. Okay, now under healthy or the normal working condition, the current will flow. Now again follow my cursor. The current will flow from in the upper feeder. It will flow from generator S1 to relay 1, relay 2. Then in this direction it will follow relay 7 and then goes to the load. In the same way, in the lower feeder the current will flow from S1 to relay 3, then relay 4, then into relay 7, then into load. So this is the normal direction of the current, that is from left to right in this half of the section. Now in this half the current will flow from generator S2 to relay 6, relay 5, and then it will flow from relay 7 to the load. So this is under normal condition, the direction of current under normal condition. Now let us assume, let us move to slide in a second. Now in this case, this bold line indicates the normal direction of current. This is for the upper feeder. This bold line indicates the direction of upper feeder. This is the line for the direction of current flowing under normal condition for the lower feeder, and this bold line is for the second section, another section of the figure. Now let us assume that there is a fault in between relay 3 and relay 4. This is the fault, this is the location of the fault. Now what happened, what, just recall that golden rule, that entire current will now feed into the fault. So the current from the lower feeder, it will follow, again follow my cursor, it will follow this direction S1, then it will goes from relay 3 to that fault. Okay, now for again for the upper feeder, it will move in this direction, that is from S1 to relay 1, relay 2, then it will come down like this, then relay 4, and it will feed into the fault. So what we have observed in this case, that under normal working condition, the current from relay 4 is flowing from left to right, but now under fault condition, the current from relay 4 is flowing from right to left. Now the direction of current is reversed after fault. So there is a need to place directional relay at position 4, and which will operate when the direction of current is given by this arrow, that is from right to left. Similarly, the same relay we need to place at position 2. How? Now let us assume there is a fault over here in between relay 1 and relay 2. Now in case of upper feeder, the direction of current is from generator S1 to relay 1, and it will feed to the fault. Fine. Now say in relay 2, in feeder 2, we will see that it is flowing from generator S1 to relay 3, then it will go to relay 4, then it will follow this path, and then it is flowing to relay 2, and now it will feed the fault. Now we have seen that in previous case, the current under normal case, the current was flowing from left to right, but now under faulty condition, the relay current will flow from right to left. So that is why we have to place the directional relay at position 2, and which will operate for the direction shown by this arrow. If the direction of current is in this direction, it will operate. Now let us see which type of relay we have to place at position 1 and position 3. Now it is clear that directional relay needed to be placed at position 2 and position 4. So for position 1 and position 3, before the occurrence of the fault, the current in the relay 1 and 3 are from left to right. This is the bold line for the normal condition for upper feeder, and this is the bold line for the direction of current for lower feeder under normal condition. After the occurrence of the fault, again the current from relay 1 and relay 3 both are in the same direction as shown by the bold line. Therefore, the relay at position 1 and relay 3 are non-directional relay. Now this symbol indicates the relay over here is non-directional. Okay, the only difference between why we are putting non-directional over here, relay over here, just because directional relay are much more costlier than non-directional relay. Now we have find out these position where to place direction and where to place non-directional relay. Now move on to the next section of the network. Here we have got relay 5 and relay 6. So under normal working condition or under normal operation, the direction of current from relay 5 to and relay 6 is from right to left. Fine. Now let us assume there is a fault in between relay 5 and relay 6. Now the current from relay 6 is still in the same direction that was prior before the occurrence of the fault. Okay, so the relay at position 6 is a non-directional relay. Fine. And let us observe the current at relay 5. Now let us follow my cursor position. Now as the fall occurs in between relay 5 and relay 6, current from generator S1 will follow this path from relay 1, relay 2. Now the current will flow in relay 5, and then it is fed to the fault. Now previously the current in relay 5 is from generator to load, that is from right to left. Now after the occurrence of the fault, the current is from left to right, so the direction of current is reversed. Therefore we are need to place a directional relay at position 5, and it will operate for the direction indicated by the arrow above. So clear na? Now we will see which type of relay we need to put at position 7. So this is load, and until and unless it is not specified, we will assume that the load is totally passive. That means it will absorb power. So always current will flow in the downward direction. There is no change of current. So there is a non-directional relay at position 7. So it is it is rarely see, mostly persons were saying that the relays near the generator ends are non-directional relay and relay at the load end is directional relay. But in this case you will see the relay at load end is also non-directional. Now we will see a different case. Now in this case, this is my load and this is my generator. These four are the position of the relays. Under normal operating condition, the current is flowing in the upper feeder as shown by this dotted line, that is from generator to relay 1, relay 2 and goes into the load. Similarly for relay for lower feeder, it will flow from generator to lower 3 to relay 3, relay 4 and then it will goes into the load. Now let us consider there is a occurrence of fault in the upper feeder. Now the current will flow in the upper feeder from generator to relay 1 and it will feed it into the fault, and in the lower feeder from generator to relay 3, relay 4 and now it will feed to the fault. Now the direction of current in relay 2 over here is reversed. See this point, the direction initially was from left to right, now the direction is from right to left, so we have to place a directional relay at this position, and similarly when the fault occurs in the lower feeder we have to place a directional relay in this position, which both will operate for the direction of current from right to left. So now in this case there is a directional relay near load, but in this case there is a non-directional relay near load. So this can be assumed, this can be easily identified by taking the direction of current. So one thing also very commonly asked in the gate exam is, if the fault occurs in this region, what are the backup relays for relay 4? Now how can we calculate the backup relays for relay 4? Now see, in this case, if the fault occurs between 3 and 4, then 3 and 4 both have to react immediately so as to eliminate this line from this healthy system, so as to eliminate this fault. Now whenever there is a fault in this occurs between relay 3 and relay 4, again in this case the current will flow in this direction from this source, so relay 5 will not operate, but relay 6 will operate, just because the current now exceeds the pickup value of the current. Therefore relay at position 6 will operate, relay at position will not operate. Now relay at position 2, again the direction of current for the feeding the fault is still same, therefore 2 will not operate. And 1, again direction of current is like this and it is non-directional relay, but the value now exceeds the pickup value of the relay 1, that's why relay at 1 will also operate. So for relay 4 the backup relays are relay 6 and relay 1. So this is the question which is being asked in the gate exam, and likewise you can identify by creating your own fault and identify which relays act as a backup relay. Thank you.